Welcome to today's session. In today's session, we will discuss one more generation technique of amplitude modulation. As in the previous session, we discussed the square law modulation technique, generation technique of amplitude modulation. In this session, today's session, we will discuss the another technique of generation circuit of amplitude modulation, that is switching modulator. Here you can observe the waveform. As the name indicates, switching modulator, we will be using a diode here which will act as a switch. Then we are applying our two inputs, message signal and carrier signal, which we are representing it as V1 of t, and a simple resistance we are using. So this is a simple circuit which is consisting of two inputs which are connected in series, and a switch we are using, that is nothing but a diode, and then a simple resistor. Now, coming to explanation. Here the carrier signal is connected in series with our modulating signal, we know that. Then the summation of x of t and c of t is given or applied to a diode. Then I will represent the v1 of t equals to x1 of t, x of t plus c of t. Then the output of the diode is passed through a bandpass filter and results in an AM wave. That we can observe in our equation also. That is, here the diode, a non-linear device, which will act as a switch. If you observe in our square law modulator, there we are using the diode as a non-linear device, so that there we applied our non-linear equation, we can achieve our output. But here this diode will act as a switch, which is, we are calling it as a switching modulator. So as it is acting as a switch, when it will be in on position and when it will be in off position, we have to see. Where the amplitude of C of t is greater than x of t, depending upon that, on and off diode is determined. Actually, if C of t is positive, means carrier signal is positive, then we will be getting our output, that is V1 of t. Means it will be in off closed position. The switch will be in closed position, so that the input message signal will be applied at the output when carrier signal amplitude is higher, means positive. We all know that for a signal there will be positive half cycle and negative half cycle. Then coming to negative half cycle of the carrier signal, as the switch will opens, then the output will be 0. Why? Because there won't be any path here to flow the input, so that this will opens, so that the output V2 of t will be 0. So here this circuit will operate depending upon the amplitude of this carrier signal. If the amplitude of carrier signal is positive, means higher, it will allows the input to pass to the output. If it is if the amplitude is lesser, carrier signal is less, 0, then the output will be 0. So that is the switch operation. Then coming to V2 of t, as it acts as switch, we can write the equation like m of t by 2 plus AC by 2 cos omega ct plus 2 pi by x of t. Why? Because it is acting as a switch, means we will be getting like this pulse signals. Like we'll be getting like pulse waveform. So this pulse waveform means off, on, off, and then on, like this. Due to this switch. So for this, the equation representation is this one. That is m of t by 2 plus ac by 2 cos omega ct plus 2 pi by 2 by pi x of t cos omega ct plus 2 pi by 2 by pi ac cos 2 omega ct. Then this is all about switching modulator. In the next session, we will see the detection techniques of amplitude modulation.